Alright, so this is finishing up lesson 6.6 for us. And example 4 says, about how many minutes does it take for a fire to spread to cover 100 acres? So in your textbook, if we read across this equation, or this problem, they came up with an equation for us. They said that an equation to cover a whole 168 or 160 acre forest, that it took, or they came up with this exponential model that it took for a fire to cover or burn a whole 160 acre forest. So they want us to know, well, how long did it take if it took, I don't even know what the book said. Let me just read it to you so that you're not that confused. All right, it actually says the diagram shows how a forest fire grows over time. The fire department can contain a 160 acre fire without needing additional resources. About how many minutes does it take for a fire to become too big for the fire department to contain without additional resources? So they came up with about 6 minutes or so for it to, before they need additional resources. But here is our equation right here that they used. Y is equal to 4 times 1.8t. They got it from that growth model there. So how many minutes will it take for the fire to spread to cover 100 acres? So I'm going to say 100 is equal to 4 times 1.8t. I'm going to divide by 4. So 100. Hold on. It should be 25 though. 25 is equal to 1.8t. At this point, guys, I can put it in logarithm form because this is A, this is B, 1.8 is B, and t is equal to e. So this becomes log of 1.8 of 25 is equal to t. I put that straight in my calculator. Remember using alpha window 5. Put 1.8 and 25. And for the fire to spread to cover 100 acres would take about 5.48 is equal to t. So about 5.48 minutes for that fire to cover 100 acres. All right, examples 5A and 5B. I actually wrote out on my sheet of paper here that we started on yesterday. I had you get out a sheet of paper for number 3. So I'm going to write 5A here as well. And I've got log base 5 of x squared minus 45 is equal to log base 5 of 4x. All right, and we may or may not, I can't remember if we discussed it in this class or not. I don't think we did. So if you want it out to the side, if you want to write log base b of x is equal to log base b of y, or if log base b of x is equal to log base b of y, then x equals y. That's another one of those logarithm properties. Everybody got that? All right, so what that means is, since these are both the same base, we can take what's in parentheses and set them equal to one another. So we've got x squared minus 45 is equal to 4x. I move the 4x to the left side, so I get x squared minus 4x minus 45 is equal to 0. And we factor. This factors in x minus 9 times x plus 5 is equal to 0. And we solve for x. So x would equal 9 and x would equal negative 5. Well, now we have to make sure they're not extraneous. We have to make sure they both work. So alpha window 5, I'm going to plug in 9 here. So 9 squared minus 45 should equal to 4 times 9. And it does. You see how those are the same? So x is equal to 9 is an answer. I'm going to try it with negative 5 now. Negative 5 squared minus 45. It gives me a non-real answer, so I automatically know negative 5 is not a correct answer.
And that's the whole run.
I was watching a chiropractor pop somebody's back earlier. Have y'all ever seen those videos and they're like... I don't know why that popped back up like that. Anyway, 5b. X equaled 9 over here. 5b, I've got the natural log of negative 4x minus 1 is equal to the natural log of 4x squared. So I've got negative 4x minus 1 is equal to 4x squared. I know you're probably wondering, well, how did I know to move the 4x to the left, or in this case, I'm moving the 4x plus 1 to the right. The reason I do that is because I try to keep my a value positive, okay? So if I keep by keeping my a value positive, I now have 4x squared plus 4x plus 1. Now I have to factor. Need something that will multiply to give me positive 4 and add together to give me a positive 4. I got 4x and 4x. So two numbers that multiply to give me 4 but add together to give me 4 would be 2 and 2. But 4x over 2 can simplify to 2x over 1 on both sides. So my two factors are 2x plus 1 times 2x plus 1. Is it necessary to set both of these equal to 0? No. You can just say 2x plus 1 equals 0, so that means 2x equals negative 1, x equals negative 1/2. I plug it in to make sure. Natural log of negative 4 times negative 1/2 minus 1 is 0. The natural log of 4 times negative 1/2 squared is also 0. So this is correct. And x is equal to negative 1/2. All right, number 6. So solve each equation by graphing and round to the nearest thousandth. So we put the left side, y1, right side, y2. If you're using your calculator, or if you're on the computer, you can use Desmos. And I think Desmos is much easier. I can't remember if we're taking our test in the computer lab or in here. But either way, you can use Desmos. So we got 3 times 2 raised to the x plus 2 minus 1. And then I've got 3 minus x. And they want to know where they intersect. They intersect at the x value of x equals negative 1.205. You just look at your x value. We're going to do the same for the next one. I've got the natural log of 3x minus 1 is equal to x minus 5, and this has 2 points of intersection, right? First one is x is equal to 0.336. Second one is x is equal to 8.156. Let Desmos do all the work for you if you can. So these are our two answers. So remember I found the ratio. I said 1.45 divided by 1.22, 1.68 divided by 1.45, and I saw that they were different ratios. So I'm going to say not a geometric sequence. All right, now I'm going to do the same for the next, for part B. 0.75 divided by negative 1.5 is negative 1/2. Negative 0.375 divided by 0.75 is again negative 1/2. So do you see how that's the same sequence? 1.875 divided by negative 0.375 is again negative 1/2. So yes, it is geometric. And they said if it is a geometric sequence, write a recursive definition for the sequence. So in your textbook, they give us the general recursive definition, and that's A sub n is equal to A1, you know that's your first term, right? A sub 1 is your first term. So A1 as n equals 1. And then A sub n minus 1 times r, where n is greater than 1. That's just the general definition of a recursive. That's a general recursive definition. We know that A sub 1 is equal to your first term, and that r is equal to your common ratio. So we're going to write a recursive definition for this sequence here. So we're going to write A sub n, because we don't know how many terms, is equal to, our first term is negative 1.5. And then we're going to write A sub n minus 1 times our common ratio. Well, let's see. We went from negative 1.5 times negative 0.5. That gives me that 0.75. I'm getting what I needed. So negative 0.5 or negative 0.5 is my common ratio. So we're going to say n has to be greater than 1, and up here n equals 1. I just wanted it to all be lined up. All right, example 2, we're going to translate between recursive and explicit definitions. So it says, recall that an explicit definition allows you to find any term in the sequence without knowing the previous term. But A says, given the recursive definition, and they give us this definition, what is the explicit definition of the sequence? So, this is our recursive definition, if you want to write that up here. Oops, sorry. I wrote recursive, and then under example 2, I'm going to write the explicit definition, and that's A sub n is equal to A sub 1 times r raised to the n minus 1, where A sub 1 is our first term, r is our common ratio, and n is equal to our term number. All right, so based off knowing what means what in the explicit and recursive definitions, we will need to figure out what our explicit definition is. So we need to know what A sub 1 is, we need to know what R is, and we need Or then that's all we really need to know because we don't know what n is. All right, so what is our first term? Our first term comes from right here. Our first term is 12. So that's what we do first, is identify that first term. Our common ratio is given to us right here in front of A. Our common ratio is 1/3. We don't have certain term numbers, so we're just going to write our explicit definition as A sub n is equal to 12 times 1/3 raised to the n minus 1. All right, so now given the explicit definition, what is the recursive definition? So again, I'm going to figure out what A sub 1 equals and what R equals. A sub 1 is going to be 6, and my ratio is going to be 1.2. So I'm going to write this as A sub n is equal to 6 at the top. At the bottom, we're going to write 1.2 times A sub n minus 1, where n has to be greater than 1 and 6n has to equal 1. You notice how I put the common ratio in front? All right, example 3 says a geometric sequence can be used to describe the growth of bacteria in an experiment. On the first day of the experiment, there were 9 bacteria, so that's going to be important. First day, there were 9 bacteria in the petri dish. On the 10th day, there were 3 raised to the 20th power bacteria in the dish. How many bacteria were in the dish on the 7th day of the experiment? So I know that A sub 1 equals 9 and A sub 10 equals 3 raised to the 20th power. That information was given to me in the word problem there. But I don't know what my ratio is. So I'm going to use the information from day 1 and day 10 to figure out what my common ratio is. So we're going to write it as an explicit definition. So we're going to write we know that A sub 10 equal 3 to the 20th. A sub 1 equals 9, and that n equals 10. I know that because that is our number of days. So I'm going to write A sub 10, or not A sub 10, we know what A sub 10 is, don't we? A sub 10 is 3 to the 20th power. 3 to the 20th power is equal to 9, which is A sub 1, so I'm referring back to my explicit definition up here, times R raised to the 10 minus 1. Well, that now leaves me with 3 to the 20th power is equal to 9 times R to the 9th power. We'll bring it over here for us. So that means that 3 to the 20th divided by 9 is equal to R to the 9th power. Right? Are y'all still with me? And then to get R by itself, we're going to take the 9th root. So the ninth root of 3 to the 20th power over 9 is equal to r. So 9 math 5, that gives me the ninth root of 3 raised to the 20th power over 9. And it tells me that r is equal to 9. Well, that's not what we need to know. We need to know how many bacteria were in the dish on the 7th day of the experiment. So I'm going to write my explicit definition. A sub n is equal to 9 times, or we can put parentheses, 9 raised to the n minus 1. Well, I need to know what it was on the 7th day. So A sub 7 is equal to 9 times 9 raised to the 7 minus 1. You put that straight in your calculator just as it looks. 9 times 9, 9 times 9 raised to the 7 minus 1. And we get on the 7th day, there were approximately 4,782,969 bacteria in the petri dish. All right, now to try to, I'm going to give you the formula to find for the sum of a finite geometric series. Because they want us to figure out basically either the sum, right here they just want us to figure out the sum. It says a geometric series is a sum of terms of a geometric sequence. S sub n represents the sum of a geometric sequence with n amount of terms. So they give us this equation, or this formula. S sub n is equal to a sub 1 times m, or not m, 1 minus r to the n over 1 minus r. Well, that doesn't just really tell me a whole lot if I don't really know what's going on in this, does it? Well, in this, I'm just going to copy it over so that we kind of see it here, so that we can label it. I've got 5, I've got n equals 1, I've got 1/2, 3 to the n minus 1. All right. This right here, if you want to label, is a sub 1. Oops, y'all can't see that. That is a sub 1. What's in parentheses is your common ratio, so that's r. What is at the top of the sigma notation is n. So the three things that you need to know for this formula are a sub 1, r, and n. A sub 1 is 1/2. R is equal to 3, and n is equal to 5. And I'm just going to plug it into this formula here. So the sum of this summation right here of these 5 terms is going to be 1/2 times 1 minus 3 to the 5th over 1 minus 3. So the sum of those 5 terms is 1/2 times 1 minus 3 raised to the 5th over 1 minus 3. And the sum of those 5 terms is 121 over 2. All right, now this says write the series. We got -2 plus -2 over 3 plus ... plus -2 over 243 using sigma notation. So what is the sum? So again, we need to figure out what a sub 1 equals. We need to figure out what r equals. And we need to figure out what n equals. So what's the first term we have in this series? -2. Well, how am I going from -2 to -2 over 3? Let's see. -2 over 3 divided by -2 is 1/3. So let's see. -2 times 1/3 is a -2 over 3. So my ratio is 1/3. My common ratio is 1/3. And I need to figure out how many terms I have. So let's see. So I guess we just have to count it up. I'll see if there was an easy shortcut to this, but I don't think there is, because they didn't tell us. No. Alright, so we're going to now say times 1 over 3, and that is our that's our third number. Our fourth number is this. Fifth number, this. Sixth number, this. So there we are. That's what we needed, right? So n is equal to 6. I'm going to see today if maybe there's or in a bit if there's an easier way for me to find that. So I'm going to write this in sigma notation. So I write that big sigma sign. And then they also want us to find the sum of this series. So we know 6 goes up here. That's our n value. N equals 1 is always at the bottom. Our first term goes first. Our common ratio is written second. And then we write n minus 1. So the sum of this, they also want to know the sum. A sub 1 times 1 minus 1/3 to the 6th power over 1 minus 1/3. -2 times 1 minus 1/3 raised to the 6th power over 1 minus 1/3. And we get the sum of these 6 terms is negative 728 over 243. All right, last example, because we're not going to do example 6. Last example says, how many terms are in this geometric series? Hey, that's what we needed for B. Let's figure out how many terms. How many terms are in this geometric series? So what we do is we go back to our explicit. Explicit, which was a sub n is equal to a sub 1 r to the n minus 1. So I know that a sub n equals 768, a sub 1 equals 3, and r is equal to 6 divided by 3 is 2. This is exactly what I needed in that last one. So I've got 768 is equal to 3 times 2 raised to the n minus 1. You cannot distribute that. So we're going to divide by 3. 768 divided by 3 is 256. Is equal to 2 raised to the n minus 1. We now write it, because look, this is in exponential form, right? We write it in the form of log. So log of 2 of 256 is equal to n minus 1. Log alpha window 5, so log base 2 of 256 is 8. So I've got 8 is equal to n minus 1. Add 1 to both sides, you get 9 is equal to n. So that means we have 9 terms in that series. So we use the explicit for A, but for B, they're talking about the sum. So we're going to have to use the sum, the formula for, trying to see what they actually call it. Just the sum of the geometric series. So we're using that formula that's at the top, 1 minus r sub n over 1 minus r. So our first term, a1, is 5. R is 2. And s sub n is equal to 155. So I plug this in. 155 is equal to 5 times 1 minus 2n over 1 minus 2. So I get 155 is equal to 5 times 1 minus 2 to the n over negative 1. Multiply both sides by negative 1. And I got negative 155 is equal to 5 times 1 minus 2 to the n power. You could distribute the 5, but what I would suggest is to divide by 5. So negative, or I'm going to tell you, actually most of your instincts are going to be to distribute. You can distribute here. So negative 155 is equal to 5 minus 10 to the n power. So that gives me a negative 160 is equal to a negative 10n. Divide both sides by negative 1, and I get 160 is equal to 10 raised to the n power. I rewrite it as log of 160 is equal to n. Or you could do log base 10, but it's the same thing. Hold on, let's see where subtracted 5, so negative 155. Hold on, because I'm not getting the answer I got earlier. Subtracted 5. Do y'all see anywhere that I may have messed up algebraically? Maybe, I mean, the only thing I can think of is I didn't distribute, so maybe that distributing has something to do with it. So don't, let me retrace my words. Don't distribute. Hope you wrote in pencil. So don't distribute there. So negative 155 divided by 5. I think that exponent's going to mess with us. Gives us a negative 31 is equal to 1 minus 2 to the n. Negative 32 is equal to negative 2 to the n power. So 32 is equal to 2 to the n. So now I get log base 2 of 32 is equal to n. And I get n equals 5. So that means that there were a total of 5 terms. Again, we're not doing example 6, and we don't have any homework in the book because you have homework on Schoology you have to complete by 11:59 tonight.
What's our homework?
Schoology.
You got test review tomorrow? You got test Friday?
Yep, test review tomorrow and test Friday.